Welcome back, folks. Let's talk about the next example, that is 3.10 in this. So we wanted to find the moment or the torque tightening the pipe. So I'm going to draw a free body diagram here. So this distance is, the wrench is 17 inches, 17 inches. And then the force which is being applied at an inclined, this is 39 Newton force is being applied, or 39 pounds force is being applied at a slope of 5 is to 5 to 12. Okay, and now we're gonna first of all draw the components of this force. So one component, because this is the point where the force is acting, so I'm gonna try and draw the components at this point, because only then I'll be able to figure out whether it's a rotating, in which direction it's gonna, the force gonna rotate. So here I will, this is the point. This is very important to understand. Although the force is being shown here, I will show it here. As long as the line of action is same, I can show it anywhere. And the idea, what the thing which we gonna do is, we will always point the arrow where the force is acting, at the point at which the force is acting, so that we can actually see which direction the that force gonna rotate. All right. So this force will have a component here, a component like this, and there will be a component like this. So now I can clearly see which direction these forces going to rotate. So if this is the vertical force, which will rotate it in the counterclockwise direction, this vertical force, and the horizontal force will rotate it in the clockwise direction. So horizontal force is trying to rotate it like this, and the vertical force is trying to rotate in the opposite direction. That's why it was really important to understand where to draw the forces. Now, now we just need to find the forces. So the slope is 5 is to 12, and this one will be 39 times, we will write it as 12. Horizontal, the vertical force will be 5 upon 13, and the horizontal force will be 39 times, uh, 39 times 12 over 13. And this is 12, this is 5, so this is 13. That's where we are getting the 13 from. Now this comes out to be, this force comes out to be 15 newtons, and the other force comes out to be 36 newtons. 36 newtons. All right. Now, this distance is 17, means from the point here where the force is acting and from where the force is being applied. And this will be 15 and 8. 15 and 8. So obviously 15, 8, and this will be 17. So the vertical components are very easy to find out uh, for this distance, because then it's, this will be 15 and this will become 8. Now just we need to finish this question. So this force is acting here, 15 newton, and this force is acting here, that is 36 newton. So I will now write it as 36 multiplied by the distance of 36 and this point, this is 15. The perpendicular distance is 36 times 15, which is negative, because this is rotating it in the clockwise direction, plus 8 times the 8 is the distance, 8 times 15. So this is rotating it in the counterclockwise direction, and that's going to give you the final answer as 420 pounds per inch. Oops, what happened? Pounds per inch. So hopefully you were able to understand how to solve this question. All right, now let's jump into the next question. On this one, we wanted to find out what is this force P. Oops, let me just quickly check. Am I recording? Yes, I am recording. I wanted to find this force P. Why I cannot write here? This is the force I'm trying to find out. And again, I'm going to first of all draw the free body diagram for this question. We are given the moment of 500 Newton meter in this question about point A. So the free body diagram is going to look something like this, and I'll call it as a complete body diagram. All these diagrams as complete body diagram. That'll be the right name. So this, these are the components. So this is P force, and this is acting at an angle of 15 degrees with the horizontal. This angle is 15 degrees. So I need to find these things, components. So the equation gonna look, how the equation is gonna look like. Moment which is equal to 500 Newton meter about point A given to me. The distance is 1.8 at an angle of 43 degrees. 43 degrees. So first of all, 1.8 1.8, this distance we can calculate, and this distance, vertical distance, we can also calculate. So the distances will come out to be, this will be 1.8 cos of 43 degrees, which is equal to 1.316, and this distance will be 1.22. I just want to tell you, if I make a calculation mistake, feel free to correct me by emailing it to me, because I'm doing a lot of calculations, so I may end up making sometimes mistake, because I'm also concentrating on recording these lectures. So now, uh, yeah, we have these values. We just need to write the equation. Moment about point A is this is P, I will call it as Px, this I will call it as Py. So Px is trying to rotate it in which direction? In the clockwise direction. So Px will be Px times 1.22 with sine of 15. Well, one second. So this, I'm calling it as Px. So Px is equal to, actually I shouldn't write it like this. So I sh so P, what is Px? First of all, Px is equal to P cos of 15 degrees, and Py is equal to P sine of 15 degrees. That's what I'm going to write it as. So you can complete a triangle here. So this value is same as this value. So you can apply the trigonometry here. This angle is 15 degrees, and P cos of 15, this will come out to be, well, Px is P sine of 15. My apologies in this case. Opposite, because this is opposite. I was about to make a mistake. P sine of 15 degrees, and here I will write it as Py as P cos of 15 degrees. Pys. So Py will be here, P cos of 15 degree in this case. Now I just need to write the equation. So the px force times it by 1.22, and this will be negative value, plus, let's say other one is plus or minus, other one will also be minus, because this is also rotating in the negative direction. I shouldn't put a negative here. Actually I should put a negative here, and 1.22 and minus Py, and this is 1.316, and then value gonna come across as Px is negative P times sine 15 degrees times 1.22 minus Py, which is equal to P sine of P cos of 15 degrees times 1.316. And you just need to do the calculation from here. That's gonna give you the value. So 500 equal to, you will get, once you're gonna solve this, you're gonna get this as negative 1.586 p, and dividing both sides by 1.586, that's going to give you the final answer. So 500, oops, I cannot switch on my calculator now. Anyhow, this value will come out to be 315 approximately, 315 negative. All right. Well, the moment was in which direction? Let me just quickly go back and look into the question about point A. About point A. So this is trying to rotate it like this. So moment value, I will actually put it as negative because moment is acting as a negative. So and negative. So you can calculate the force value is 315. So hopefully you were able to understand this question. All right, that's it for this video. I will see you with another video. Till then, goodbye.